Good morning, students. In this video lecture, I am going to discuss the application of inductive effect. That is, why we study inductive effect and what are the different applications of inductive effect. So, the topic is application of inductive effect. As you know, inductive effect is of two types. One is called your plus I or positive inductive effect, while second is your minus I or negative inductive effect. So we have to discuss basically the application of both the positive and negative inductive effect. The first application is, it is used to explain the stability of a carbocation and carbonyl. The simple idea is the presence of plus I group, that is electron donating group, will increase the stability of a carbocation. However, it will decrease the stability of a carbonyl. That is the first point. The second point is greater the number of plus I group, that is EDZ group, electron donating group, greater will be the stability of a carbocation, while the stability of carbonyl will डिक्रीज। तो नेचुरल है कि जो चीज कार्बोकेटाइन को स्टेबल करेगा वो चीज आपके कार्बोनाइन को डिक्रीज करेगा। मीन्स डिक्रीज करने का मतलब उसके स्टेबिलिटी को डिक्रीज करेगा। नाउ लेट अस सी एन एग्जांपल। Suppose we have a carbocation of this type, that is tertiary butyl carbocation. We know that it is more stable than a secondary carbocation, which is further more stable than a primary carbocation, and which is further more stable than this methyl carbocation. Now what happens in all the carbocations? We have positive charge on carbon. In all the carbocations we have positive charge on carbon. The simple principle is greater is the dispersal, or delocalization of charge, that is in this case positive charge, greater will be the stability of carbocation. So if it is carbon ion, then there will be negative charge. Then we have to see the dispersal of negative charge. But in case of carbocation, as we have positive charge on carbon atom, so we have to consider the delocalization of the positive charge. यानी ये पॉजिटिव चार्ज जितना ज़्यादा आपका स्प्रेड रहेगा, जितना ज़्यादा डिलोकलाइज रहेगा, जितना ज़्यादा ये बिखरा रहेगा, यहाँ से जितना ज़्यादा ये दूर रहेगा, then that carbocation will be your most stable. Now you know this is alkyl group, this is methyl group which is of plus I character. This is methyl group which is of your plus I character, that is your electron donating group. Now this is one methyl group, this is another methyl group, this is third methyl group. So this methyl group will donate electron pair to this positive charge carbon. आखिर ये मिथाइल ग्रुप क्या करेगा? ये मिथाइल ग्रुप अपना इलेक्ट्रॉन पेयर इस पॉजिटिव चार्ज कार्बन को रिलीज करेगा. Similarly, this methyl group, which is also electron donating group, it will release electron pair to this carbon. And again, this third methyl group, it will also release electron pair to this positive charge carbon. Means the positive charge of carbon is delocalized by electrons donated by these three methyl groups. However, in this case, there are only two methyl groups. This is of electron releasing character. Again, this is of electron releasing character. So here we have 3 plus I group. Here we have 3 plus I group. Because you know, methyl group are plus I. Here we have 2 plus I group. Here we have 2 plus I group. Now what happens in this primary carbocation? In this case, we have only 1 plus I group. आप देखिए ये जो आपका इथाइल कार्बोकेटाइन है ना, इस केस में we have only 1 plus I group. But in case of your methyl carbocation, the positive charge present on carbon is not attached with any of the alkyl group. पॉजिटिव चार्ज जिस कार्बन पे है उस कार्बन से कोई अल्काइल ग्रुप अटैच नहीं है. ओनली 3 हाइड्रोजन्स आर अटैच्ड. So we can say no plus I group is attached to your positively charged carbon. Now I have already discussed that the presence of a plus I group will increase the stability of a carbocation. Now in this case there are 3 plus I group. In this case there are 2 plus I group. In this case there is only 1 plus I group. In this case there is no plus I group. So due to the presence of 3 plus I group, a tertiary carbocation is most stable, and then there will be secondary, and then primary. However, your methyl carbocation is least stable. Now, let us consider the stability of a carbon ion. Let us consider the stability of a carbon ion. So, in case of carbon ion, this is your negative charge. In case of, again this will be your negative charge, and this is your negative charge. Now, in tertiary carbon ion, there are 3 plus I group. 3 plus I group in case of your tertiary carbon ion. You know, they are electron donating group. So what happens? This methyl will donate electron to this carbon. This methyl again donate electron to this carbon, and this methyl will donate electron to this carbon. It means in tertiary carbocation, not delocalization, but there is localization. We can write on tertiary carbon ion, electrons are totally localized. It is not delocalized, but it is totally localized. Means you can say there is crowding of electron, and that's why this carbon ion will be least stable carbon ion. अब तो कोई प्रॉब्लम नहीं होना चाहिए. In this case there are 2 plus I, so there is less localization. In this case there is 1 plus I, so there is again further less localization, while in this case there is no localization. So your methyl carbon ion becomes most stable carbon ion. However, your tertiary butyl carbon ion is your least stable carbon ion. तो जो tertiary butyl carbocation आपका most stable था, याद करेंगे, वहीं पे आपका tertiary butyl carbon ion least stable हो गया. मिथाइल कार्बोकेटाइन जो least stable था, लेकिन मिथाइल कार्बन आयन आपका most stable हो गया. So this is one of the main application of your inductive effect. Now let us see another application of inductive effect. The second application is it explains the relative strength of acids. It explains the relative strength of acid. Okay, whether acid is more stronger or whether an acid is less strong. Now what are the effects? The presence of a minus I group, that is electron withdrawing group, EWG, that is electron withdrawing group, will increase the acid strength, while the presence of plus I group will decrease. That is point number 1. The second point, you can say that what will be the second point in this context? Greater the number of minus I group, greater the number of minus I groups, stronger will be the acid, and vice versa. वाइस वर्सा का मतलब हुआ कि जितना कम माइनस आई ग्रुप रहेगा एसिड स्ट्रॉन्ग होगा मगर उतना कम होगा। दूसरा सेंस आप कह सकते हो कि ग्रेटर द नंबर ऑफ प्लस आई ग्रुप वीकर विल बी दी एसिड। तो आई होप लैंग्वेज आर वेरी मच क्लियर। नाउ लेट अस सी सम एग्जांपल्स। Let us see some example. For example, we have acids like formic acid, and we have acids like, say, acetic acid. Now you know acid are those substances which will donate proton, and if you facilitate in the tendency of donation of proton means the acid will be more strong, क्योंकि आप जानते हो कि एसिड वो है जो प्रोटॉन दे। तो प्रोटॉन देने की टेंडेंसी को यदि हम बढ़ा सकें इसका मतलब मैंने एसिड को स्ट्रॉन्ग किया, और अगर उसके प्रोटॉन डोनेटिंग टेंडेंसी को रिड्यूस कर दिया मीन्स हमारा एसिड जो है वो वीक हो गया। नाउ व्हाट हैपेंस इन दिस केस, सी दिस इज एसिडिक ग्रुप, दिस इज योर एसिडिक ग्रुप। नाउ हियर वी हैव हाइड्रोजन, बट इन दिस केस विथ एसिड ग्रुप द अटैच्ड ग्रुप इज योर मिथाइल ग्रुप। आप देखिए यहां आपका एसिड फंक्शनल ग्रुप से मिथाइल लगा हुआ है, एंड मिथाइल इज ऑफ योर plus I character, that is your electron donating group. However यहाँ जो हाइड्रोजन है ना, it is neither plus I nor minus I, you can say it is neutral। ये इलेक्ट्रॉन न देगा इस कार्बन को और न ही वहां से लेगा। However this methyl will donate electron to this carbon. It means the proton release will decrease, because we know the presence of a plus I group will decrease the acid strength. Therefore your formic acid is more stronger than your acetic acid. ये डिटेल और आप क्लास 12th में पढ़ोगे। Now let us suppose we have to consider, say this is your acetic acid, this is your bromoacetic acid. Now what happens in this case, this is bromine. Bromine is your electron withdrawing group, that is minus I group। हमने क्या पढ़ा है? हमने पढ़ा है कि the presence of minus I group will increase the acid strength। यहाँ एक देखिए ब्रोमीन जो है वो माइनस आई ग्रुप है, इसलिए ये क्या करेगा, एसिड के स्ट्रेंथ को इंक्रीज करेगा। इट मीन्स योर ब्रोमोएसिटिक एसिड इज मोर स्ट्रॉन्गर देन योर एसिटिक एसिड। सिमिलरली लेट अस सपोज we have examples of this type। Say this is your CH2F COOH। What is this? This is your fluoroacetic acid। I am not concerned with the IUPAC name, ठीक है, ये फ्लोरोएसिटिक एसिड इसका कॉमन नेम है, नो प्रॉब्लम। Another is CH2Cl COOH, that is your chloroacetic acid। Next is suppose CH2Br COOH, that is your bromoacetic acid। suppose it is A, suppose it is B, suppose it is C. अब देखिए ये भी माइनस आई है, फ्लोरो माइनस आई, ये भी माइनस आई है इलेक्ट्रॉन विड्रॉइंग, and it is also minus I. So in all three examples we have one minus I. Now the question is कि जो ज्यादा स्ट्रॉन्गर माइनस I होगा वो एसिड ज्यादा स्ट्रॉन्ग होगा. You know, fluorine more minus I than chlorine, more minus I than your bromine. It means A is more stronger acid than B, and further B is more stronger acid than C. क्योंकि ये जो फ्लोरीन है ना सबसे ज्यादा माइनस आई है, जबकि ब्रोमीन इन तीनों में कम है. Now let us consider one more example. Let us consider one more example. For example, we have acids like CH2Cl, COOH. Say this is your, better to write hydrogen, hydrogen. Another example is CH, Cl, Cl and COOH. The third is chlorine, Cl, Cl, COOH. Now say it is your A, this is your B, this is your C. Now what happens in this case? There is only one minus I group, that is chlorine. Here we have two minus I group, दो minus I. इस केस में देखिए, here we have three minus I. Here we have three minus I. So it is your trichloroacetic acid, dichloroacetic acid, monochloroacetic acid. Greater the number of minus I group, stronger will be the acid. जितना ज्यादा माइनस आई होगा एसिड उतना ही स्ट्रॉन्ग होगा. यानी आप कह सकते हो C is more stronger than B and further your B is more stronger than A. I hope it is sufficient. Now next is, that is the last application of your inductive effect. It is used to compare the strength of base. It is used to compare the strength of base. Presence of plus I will increase the base strength, For example, we have a question. Methylamine is a stronger base than your ammonia. क्या होगा? Your methylamine is more basic than ammonia. The question is why? For example, if we have, this is your ammonia. You know ammonia is pyramidal with a lone pair of electron. Since it has a lone pair of electron, so it is your Lewis base. आप आगे पढ़ोगे केमिकल इक्विलिब्रियम में लुईस बेस उसको कहते हैं जिसके पास एक लोन पेयर ऑफ इलेक्ट्रॉन हो. Similarly, in case of methylamine, there is also a lone pair of electron. ये देखिए यहाँ मिथाइलामीन में भी लोन पेयर ऑफ इलेक्ट्रॉन है, तो ये भी लुईस बेस हुआ, ये भी बेस हुआ. It is base. But the question is कि वह कौन है जो बड़ी आसानी से इलेक्ट्रॉन पेयर देगा. Which one will release electron pair more easily? If you consider in methylamine, this methyl group is your plus sign. ये इलेक्ट्रॉन डोनेटिंग है. डोनेटिंग का मतलब क्या हुआ? It will donate electron pair to nitrogen. It will donate electron pair to nitrogen. Means there is more localization of electron on nitrogen. जब ये मिथाइल ग्रुप इलेक्ट्रॉन पेयर देगा तो किसको देगा? भाई when this methyl group will donate electron pair, naturally it will donate electron pair to nitrogen. Then there is overcrowding of electron on nitrogen. There is localization of electron on nitrogen. So nitrogen will easily donate electron pair, and therefore you can say this methylamine is more basic than your ammonia. अब मान लीजिए एक नहीं, अगर हमारे पास दो दो मिथाइल ग्रुप हो जाता, आप कह सकते थे सर एक नहीं, यहाँ 2 + I ग्रुप हैं, there are 2 + I group, then what will happen? तब क्या होगा सर? Naturally you can say this amine, that is your dimethylamine. This dimethylamine is more basic than your methylamine. तब आप इसको more basic कहिए इसके comparison में. Now I hope there should be no difficulty to understand what is inductive effect and what are the different application of your inductive effect. Thank you.